Okay, we're looking at decimals, and we'll first do a brief intro on what we mean by place value. This often comes up when we deal with decimals. And then we'll just focus on the four main operators that we can use when we're, for example, adding decimals together. So what is place value? What do we mean by place value? What, all this means is, that each column has its own kind of multiplier, right? So this is our hundreds column, our tens column, our units column, our tenths column, and our hundreds column. So we could have an example. Let's say we've got, say, 432.17. Well, in this case, because for example, the 3 is actually in my tens column, the 3 actually has a value of 30. And because the 7 is in my hundredths column, the 7 actually has a value of 700ths. So that's what we mean by place value. Every digit has its own actual value in a number. So let's now focus on the operations. So let's do adding first. Well, adding decimals together is very, very much the same as what we're used to with regular whole numbers. So, for example, we could do, say, I don't know, let's say we want to do 32.7 plus 15.8. Well, in this case, I actually might just simplify it slightly. Let's do 5.8. So in this case, all we're doing is, as we normally do, we just add the columns together, right? So 7 plus 8 gives me 15. I carry the 1 from the 15. I then do 5 plus 2, I get 7, plus the 1, I get 8. And then I do 3 plus nothing, and I get 3. And so that's how we can add together decimals. We just need to remember to keep our decimal point in that same column. We don't want to move our decimal point around at all. Minusing is also the exact same as we used to. I could keep the same numbers together. We could do 32.7 minus 5.8. When in this case, I can't do 7 minus 8 because I get a negative number. So I steal from the column over. I turn that 2 into a 1, and I take the 1 from this column and I give it to this column next to it, so that anything in this column is 10 times bigger than in the column next to it. So a 1 here actually becomes a 10 here. So this 7 becomes a 17. And then we can do 17 minus 8. That gives us 9, and put the point in there as we always do. We can then do 1 minus 5. Well, we can't do that because we get a negative number again. So we can steal from the 3, turn that into a 2, and we can do 11 minus 5. Well, 11 minus 5 gives us 6. And we can then do 2 minus nothing, and we get 2. So we get 26.9. Timesing and dividing are, slightly different beasts. So let's say we wanted to times two decimals together. Let's keep it the same, right? So let's say we wanted to do 32.7 times 5.8. Well, this is is easy to slip up here because doing 0.7 times 0.8, we actually have to put our answer not in this column, not in the column over, but in the column over from that. We've got to, the fact that we've got 7 in the tenths rather than in the units column means we've got to shift over by 1, and the fact that there's 8 is in the tenths column rather than in the usual units column means we've got to shift down again, right? Because our actual answer is going to be 100 times smaller than what we'd normally expect if we did 7 times 8. Well, so we can do this method if we want to. It's much easier in a way to kind of artificially turn this into a much nicer question. So we can actually turn this into a nice question by just timesing the top by 10 and timesing the bottom by 10 as well. So I end up with 327 times 58. And at the very end, I know that my answer is going to be 100 times too big, right? Because I've times this one by 10 and I've times this one by 10. So, I can do this standard multiplication now. I could go through all these steps. 8 times 7 is 56. I carry the 5, put the 6 there. 8 times 2 is going to give me 16 plus the 5, 21. I could go through this. I won't do it all now, but 8 times 3 is 24 plus the 2 is 26. And I could do the same thing for all of my numbers, and I could add them all up together. I get another line here. I'd add that up together, and I'd get some answer. And at the very end, I'd take that answer and I would divide it by 100, because I know that this number is 10 times too big, and this number is 10 times too big. So that's how we can do timesing. We'll go through an actual exam question in a second. Dividing, again, it's very similar to what you're used to. Yeah, let's say we wanted to do 32.7 divided by 5.8. Well, again, in this case, we can either think of this as 32.7 divided by 5.8, and we could set up our bus stop method that we're probably fairly familiar with. 32.8. You may have seen this kind of a layout before. And we could do 5.8 into 3 doesn't go. 5.8 into 32. Yeah, we can put 5.8 into 32 probably by 5 times. And then we can work out the remainder, and we could put it in front of the 7. Or what we can do is, it's actually easier to manipulate this rather than the timesing. I can take this number, and again, I can times it by 10, and I can take this number, and I can times it by 10. And actually, that won't change the final result, right? We know that, for example, I don't know, like 40 divided by 20 is 2, as is 4 divided by 2, right? They equal the same thing. So it doesn't really matter if it's 10 times bigger or 10 times smaller. I get the same answer either way when I do a divide. So in this case, I could probably make this a bit nicer for myself by just turning these into regular whole numbers, and I could do that kind of standard bus stop method, and eventually I'd get down to my answer. Again, I won't go through all this now. We're going to do a practice exam question in a second. So yeah, let's go on now and do some actual questions. So we're going to do an adding, a timesing, and a dividing. Obviously, adding and minusing are almost the exact same, so we'll just do one of these. Right, so if we're doing 0.89 plus 0.113, well, we're going to lay this out as we did on the previous page. So we've got 0.89 plus 0.113. And I might just put a 0 there just to make it slightly easier. So we do 0 plus 3, we get 3. 1 plus 9, we get 10, so we carry the 1. A plus 1 plus 1, we get 10, so we carry the 1 again. And 0 plus 0 is just 0, add the 1, you get 1. And our decimal point, again, stays in that same column as it always does. So our final answer is going to be 1.003. Timesing. So again, it's it's tempting to try and do this. I think it's easier to slip up if we just try to dive straight in to doing 002 times 043. It's easy to slip up, right? We're not quite sure exactly how many kind of columns over we have to shift until we hit the right column, right? This is actually 2/1000ths times 3/1000ths. What we can do to make it easier for ourselves is a bit of a tricky one. We can actually times both sides, the top and the bottom, by 1,000. And what's that gonna do is, if we zoom in, well, timesing this by 1,000 is going to move my decimal place across 3 places. And same here, this decimal point is going to shift 3 columns. And so this is going to become 2 times 43. Which we can do, right? We can know what 2 times 43 is fairly easy, right? 2 times 3 is 6, 2 times 4 is 8. And so we end up with 86. But this isn't the final answer, right? We know that this is 1,000 times too big, and this one is also 1,000 times too big. And so our final answer is going to be 1,000 times 1,000 times too big. So we've got to take this 86, and we've got to divide it by, not by 6, by 1 million, because that's going to be equal to 1,000, right? This is taking account of the fact that we've times it by 1,000. Again, we've times it by 1,000 a second time. So 86 divided by a million. Well, all we do here is we take our decimal point and we just shift it up 6 places in this case. So it's going to be 1, 2, 3, 4, 5, 6. And so that is going to be my final answer. It's going to be 0.00000 6.86. Right, the final question, dividing. So let's look at this. So we've got 7.488 divided by 1.2. And again, yeah, it's tempting to have a go at this. We could just have a go at this and keep the decimal points in. I want to make it slightly nicer, and I'm going to times this by 10 and times this by 10. So our final answer isn't going to change at all. It's the same as doing either 40 over 20, like I said before, or 4 over 2, right? It doesn't matter if both are 10 times bigger. I could equally do 400 over 200. I get the exact same answer every time. I just get 2 in this example. So I'm actually going to change this, and I'm going to do 12 into 74.88. So let's have a go at this. So can I fit 12 into 7? No, I can't fit 12 into 7. Can I fit 12 into 74? Yeah. I just need to figure out how many times. Or 12 times 5 is 60. 12 times 6 gives me 72. So I can fit it in 6 full times with a remainder of 2. I know that 2 times 12 is 24, and that's the maximum I can make. So I can fit 2 more 12s into 28. So 2 12s gives me 24. I've got a remainder of 4, so I carry that over. And 12s into 48 goes very nicely. It goes 4 times. And again, I need to make sure that I keep my decimal point in that same place. And so our answer in this case is going to be 6.24. And that is the end of decimals.